This is Austin Konkle. This is my submission for the Talk Me Through Your Solution problem for exam 3. You're supposed to compare the proportions of mowers requiring further service between suppliers A and B at a 10% level of significance. So for my problem, started out just quick summary of the problem, testing at a 10% level of significance whether there is a difference between the proportion of the two suppliers' engines needing serviced. So for supplier A, the proportion is 13 out of 100 or 0.13. Supplier B, the proportion is 10 out of 100 or 0.10. For step 1, we're writing the null hypothesis, and your options are whether it's a left-tailed, right-tailed, or a two-tailed test for HA. I chose 0 as the D0 value because we're basically looking for any difference in the two, not specifically a 0.50 difference or anything like that. And then for my alternative hypothesis, I chose to do a right-tailed test. I think this could have been a two-tailed test just by the way it's worded, because we're looking for any difference, so you could check on either side. But because there are the same number of mowers from each supplier, I think it's simpler to go this route and just check to see if P1, which is the supplier with a greater portion of engines needing serviced, is different enough from P2 at a value for A equals 0.10. Forgot to write that in. So for step 2, since we're looking for the difference in a population proportion, the test statistic is this equation, which I will not read all the way out, but in plugging it in down here, we get on the top 0.03 because of P1 minus P2. We're subtracting 0 from that, so that doesn't matter. And then on the bottom, we have 0.13 times 0.87 divided by 100 plus 0.10 times 0.90 divided by 100. And you math all that out, it equals 0.03 divided by 0.002. And that equals a z-value of 14.77. And then for step 4, since HA is a right-tailed test, in this case, there's a critical value at ZA, which is Z of 0.10. And if we look in the critical values of T figure A3, we look down here at the bottom at a value of 0.10, which is 10%. Go all the way down to the bottom, we have 1.282. So that is our z-value for the rejection region. And then so the rejection region is 1.282 to positive infinity. And then step 5, as shown in the figure below, the test statistic falls in the rejection region. And so if we look on the figure, you can see that from 1.282 to infinity, 14.77 is in that rejection region. So reject H0 would be in this area. From that, the decision is to reject H0. In the context of the problem, the conclusion is the data provide at a 10% level of significance to conclude that there is a difference in proportion of mowers requiring further service between suppliers A and B.